Okay, so you're going to listen to this video and you're going to copy down the notes, which is really just filling in the blanks and showing examples for each of these divisibility rules. And then we're going to use divisibility rules to help us determine if numbers are prime or composite. So the first divisibility rule we're going to look at is determining if a number is divisible by 2. And this is probably one you have memorized. But determining if a number is divisible by 2 requires looking at the last digit. And if the last digit is even, or the number 0, then you know the entire number is divisible by 2. So a couple of examples. 2,468, big number, but I know that it is divisible by 2 because I look at that last digit, 8, and 8 is an even number. So then I know the whole number is divisible by 2. Whereas if I looked at a big number like 10,531, I would know right away that number is not divisible by 2 because I look at its last digit 1. That's odd. It can't be divisible by 2. And then, like you saw in your warm-up today, a number is divisible by 3 if the sum of the digits is divisible by 3. So for instance, that 2,468 I already used to see if it was divisible by 2. Well, now I'm going to determine if it's divisible by 3. So I add the digits or sum them together. 2 plus 4 is 6. 6 plus 6 is 12. 12 plus 8 is 20. 20 is not divisible by 3. It's not in my 3 times tables, so I know that that number is not going to be divisible. The entire number, 2,468, is not divisible by 3 as well. Let's say we take the number 324 to see if it's divisible by 3. So again, I would sum the number. Or the digits, sorry. 3 plus 2 is 5, 5 plus 4 is 9, and 9 is divisible by 3. Therefore, 324 would also be divisible by 3. Okay. The next rule is to see if a number is divisible by 4, and if it's divisible by 4, the number made by the last 2 digits. Okay, if that number is divisible by 4, then the entire number would be. Okay, so let me use that example from the last one. 324. I'm only going to look at its last 2 digits, and if those last 2 digits are divisible by 4, then I know that the whole thing is. And 24 is divisible by 4. 24 divided by 4 is 6, so then I know the entire thing, 324, is also divisible by 4. Okay, another number. We could try 10. Let's go back to that 10,000. The one I used for the first one, 10,531. Okay, if I look at just those last 2 digits again, 31, I know that 4 times 8 is 32. And 4 times 7 is 28, so since 31's in between those, it's not divisible by 4. Therefore, the entire number 10,531 would not be divisible by 4. Alright, this one is another one you probably have memorized, but we're going to make sure we have it on paper just in case. A number is divisible by 5 if the last digit, so again we're just looking at the last digit, is either 5 or 0. So you can see that in your multiplication tables. 1 times 5 is 5, 2 times 5 is 10, 3 times 5 is 15, 4 times 5 is 20, 5 times 5 is 25. They all end in 0s or 10s. So if I have a large number like, let's just do 1,100. Sorry, that was supposed to be a comma. 1,165. I still know it's divisible by 5. because I just have to look at that last digit, and since it's a 5, it's good. Say I had a big number like, I don't know, 33,652. I know that one's not going to be divisible by 5 because 2 is the last digit instead of 5 or 0. Okay. All right, so the divisibility rule for 6. A number is divisible by 6 if it passes 2 tests. It has to be divisible by 2. So if you look back at your 2 rule, it has to end in an even number. The last digit's even or it's 0. And it also has to pass the divisibility rule for 3. So if you think about that, 2 times 3 is 6. So in order for it to be divisible by 6, it has to pass both those rules. So let's test this one out real quick. That 324 we saw before. Okay, I know it's going to pass the rule for 2 because it's got an even number in that last digit. And 3 plus 2 plus 4, 3 plus 2 is 5, plus 4 is 9. I think we saw that earlier. And 9 is divisible by 3, so it also passes that 3 test. Therefore, it is divisible by 6 as well. Okay. If you had something like 750, you might not be sure if it's going to be divisible by 6. So first you check, does it pass the rule of divisibility for 2? Well, yeah, it ends in a 0. And does it pass the divisibility rule for 3? So you sum up those digits. 7 plus 5 would be 12, plus 0 is 12 still, and 12 is divisible by 3. So since it passes both tests, then 750 is also divisible by 6. Okay, a number is divisible by 9 if the sum of the digits, so similar to the 3 rule, we're summing the digits, if the sum of the digits is divisible by 9. Now, 9's a lot bigger number, so sometimes you won't know if the sum of the digits is divisible by 9. You might have to actually work it out. But here's an example. We could even go back to that 324. I add the sum, or find the sum of the digits by adding them together. 3 plus 2 again is 5, plus 4. That's 9, and we know 9 is divisible by 9. So the whole number 324 is also divisible by 9. Another example might be if I had 8,000 and 8,001. Okay, you sum up those digits again, that's 9. It won't always sum to 9. I'll give you one more example just because that was probably not the best one. But again, we know 9 is divisible by 9, so that whole number would be divisible by 9. One more example would be, let's say, 5,205. Okay, if I add those up, that's 7 plus 5. Okay, so that one would be a sum of 12. 12 is not divisible by 9. So that number is not divisible by 9. Okay, and this is last one is another one you should know. A number is divisible by 10 if the last digit is 0. So 10, 20, 30, 40, they all end in zeros. So all you have to check on those is the last digit. You got a really big number like 500,220. Well, we know that number is still divisible by 10 because it ends in a 0. But if you have another big number like 22,981, we know that one is not divisible by 10 because the last digit is not a 0. Okay, so if you flip your paper over, now we're gonna use those divisibility rules to determine the prime numbers between 1 and 100. Prime and composite are words you hopefully heard in elementary school, but we will review their definitions right now. A prime number is going to have exactly two factors, 1 and itself. Can't have any more, can't have any less. So technically 1, the number 1, is not a prime number because 1's only factors are itself. It's also not a composite number because composite numbers have to have more than two factors. So 1 is neither prime or composite. It's a pretty interesting math fact right there. Okay. But for example, the number 2 would be prime because its only factors are 1 and itself. Those are the only positive whole numbers I can multiply together to get 2. Whereas the number 9 is composite because I can multiply 1 times 9, but I could also multiply 3 times 3. Okay, so it has more than two factors, therefore it's composite. So what we're going to do now that we know what prime and composite numbers are, is we're going to take this hundreds chart you have, and we are going to determine all the prime numbers. Now, we're not going to go through and just be like, oh, that number's prime, that number's composite. What we're going to do is we're going to shade or place an X on the composite numbers, and then what's left should be our prime numbers. So using those divisibility rules, I'm going to start with numbers I know that are even. Now you got to be careful. Just like we're not going to do anything to 1, we're not going to circle it because it's not prime. And we're not going to place an X on it because it's not composite. So 1 we're just going to leave alone. But 2 is an interesting one because, as I already mentioned, 2 is prime. So we can circle that one. Okay? But 2 is also the only even number that is prime because every other even number is going to have 2 as a factor. So that means other than 2, if it's even, we can shade it or X it out. So that's all these numbers that end in 2, where the last digit is 2, they're getting X'd out. They're all composite. 4 is even, and everything that ends in 4 is even. So we're going to X all those out. 6 is even, and any number with the last digit of 6 is even. So we're going to cross all those out. Okay, 8 is even, and all the numbers with the last digit of 8 are even. Okay, 10 is also even, and all the numbers that end in 0 are even. We saw that in our divisibility rules. Okay, so now that we've taken care of the even numbers, we've almost knocked out half of the list. So the next divisibility rule we're going to think about, and really we won't need it till a little while from now, but 3s, because you guys have your 3 times tables memorized, but 3 itself, we're going to circle, is prime, because 3's only factors are 1 and 3. But then now any multiples of 3 that we haven't already crossed out because they were even, we have to cross out as composite numbers. So like 9. 6 was already crossed out because it's even, but 9, as I mentioned in my example, 9 is composite. 12 would be the next one. It's already crossed out. 15. 18's crossed out. 21. 24 is already crossed out. 27. 30. 33. 36. Okay, and that's 3 times 12. So that's where most of us don't remember our times tables anymore. So this is where you can just keep counting by 3. So 36, 1, 2, 3, 39. Or you could start using that divisibility rule of 3. I'm just going to keep counting. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay. All right, so 4 is already crossed out because it's even. 5 is a prime number. We're going to circle it. 5's only factors are 1 and itself. And then the nice thing about 5 again is that we just have to look at the last digit. So anything that ends in a 5, let me switch back to my highlighter. Anything that ends in a 5 that isn't already crossed out, we're going to cross out. And anything that ends in a 0, well, all of those zeros, where the last digit is 0 over here on the right, those are already crossed out because they're all even. That means we're ready to circle number 7, because 7's only factors are 1 in itself. Okay. Now we didn't have a divisibility rule for 7. It's kind of one of those tricky ones where if you want to know if a number is divisible by 7, you got to divide it out. In this case, I'm going to kind of give them to you, but basically I'm going to do the same thing I did with the 3's. I can check my times tables first. So 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21, 7 times 4 is 28, 7 times 5 is 35, 7 times 6 is 42. I'm just looking for any in the times tables that aren't already crossed out. It's like 7 times 7 is 49, so we need to cross that one out. 7 times 8 is 56, 7 times 9 is 63, 7 times 10 is 70, 7 times 11 is 77, so we need to get rid of that one. And 7 times 12 is 84. Okay, so from here I'm going to count though. 1, 2, 3, 4, 5, 6, 7. So 91 you may have thought was a prime number, but 91 is actually divisible by 7. 1, 2, 3, 4, 5, 6, 7. And then 98's already crossed out, and the next multiple would be past 100. All right, almost there. Prime numbers where 8, 9, 10 are already crossed out. 11 is prime, so we're going to circle it. 1 times 11 is 11. There are no other factors of 11. Multiples of 11 are kind of easy to work with. 22 is already crossed out. Notice this diagonal. 22, 33, 44, 55, 66, 77, 88, 99. So all the multiples of 11 are already crossed out for us. They were all divisible by something else as well. 13. Okay, so like I said, I'm going to start giving these to you. The ones that are left. Sorry, allergies. 13 is prime, so circle that. 17 is also prime. 23, 19 is prime. Sorry, I almost skipped that one. 23 is prime. 29 is prime. 31 is prime. So is 37. 41 and 43 and 47 are all prime. 53 and 59. 61 and 67. 71, 73, and 79. 83 and 89 are prime. And then the only number in the 90s that's prime is 97. So we now have circled all the prime numbers between 1 and 100. Again, we wouldn't circle 1. 1 is neither prime nor composite.